That's why I quit with it. So 4.2 is binomial distributions. 4.1 was probability distributions. Now it's binomial distributions. Binomial distributions. And I had your homework open whenever I did this. I got an example of all the different problems. This first page is going to kind of just be like explaining the binomial experiments and doing the notation, and then we're just going to go straight into examples. So you have to like write all of those words, but it's not too bad today. Let's switch my blacks. Let's see. Okay, so binomial experiments. This one's worse than the other one. Binomial experiments. So when we talk about binomial experiments, I can't talk, experiments, we're talking about an experiment that has repeated trials where each trial is independent. And independent, obviously, just means that, one trial does not affect the other trial. Okay, they're independent of each other. Okay, so we have these two different outcomes. There's only two whenever we talk about binomial, right? Bi meaning two. When we talk about binomial experiments, what we have is we have success. It's a weird word, successes. And it's represented with like a capital S. I didn't see a lot of them talking about the successes and the failures, like a tree diagram or anything. But just know that with a binomial, there's only those two outcomes. And then with failures, it's going to be represented with a capital F.
So this one, what's your 4.2 should be way quicker than
There's only 13 problems, and okay, so in grad school, one of the best things that I ever was taught about math is that if you can see a pattern, that obviously it makes life easier. And I noticed that with this. I mean, it's literally just the exact same thing over and over again. Very little things change. And because of that, it's kind of redundant, to do it and write it all out, but the math is not hard. And so I do believe it'll be a lot quicker than 4.1. Okay, so successes, which is our capital S, and then failures are only two outcomes. We can say are the only two outcomes. I don't know how, but I almost spelled outcomes wrong. Okay, so those are the two different things. You got that the outcome could be a success or it's going to be a failure, period, nothing more. Okay, now P of S, a capital P of S, like the probability of successes is the same for each trial, and that's because they're independent of each other. This happening does not affect anything else, so the probability of a success is going to be the same for each and every single one. And then lastly, we have random variable X counts the successful trials. It's getting worse and worse. Probably just take it off. I'm not really liking how this is writing because it's dying, so I'm going to switch to purple. Okay, so binomial distributions has two different outcomes, only two outcomes, a success or a failure. All of the trials have to be independent. Okay, that's what makes it a binomial experiment, is that the trials are independent. They do not depend on each other and they're not affected by each other. Okay, and so I'm going to go and break down like this different notation whenever we talk about these binomial experiments. So we have our like lowercase n. It's like kind of like a cursive n. And our n is the number of times the trial is repeated. Okay? The number of times trial is repeated. Maybe, probably, I don't know what that one's supposed to be. So we have a doctor, or we have this, or we have this other kind of experiment, and there's so much of a success rate, and they perform this procedure or whatever, so many different times. That would be our n. That's the number of times that this trial is going to be repeated. And then we have, it's like a lowercase p. I think I have a Band-Aid on that. Okay, and it's actually the probability of success in single trial. So probability of success in single trial. And remember, we only have the two different outcomes. We're either going to have a success or we're going to have a failure, right? So P is represented of all the success, the probability of all the success in a single trial, and then our Q is the probability of failure in a single trial. And the way that we would solve for Q, we're talking about probability, right? And probability, like if something's for certain, it's like the probability equals 1. And so we're going to use our 1 and subtract our successes, and that's how we compute what our failures are. Katie, you want to come up here? I feel like it's so hard to see back there. Yeah, I don't. Apparently Dominic's not going to be here today, so hop on up here. Okay, so N is the number of trials. Yeah, well, or now after class, whatever. N is the number of times the trial is going to be repeated. P is the probability of success in a single trial. Q is the probability of failure in a single trial. You take 1 and you subtract your successes in order to get your failures. And then lastly, we have X, which is a count of the number of successes in trials. So I'm going to just write that, okay? A count of I think I started doing hashtag pound sign after a while. I feel like I wrote number a lot. Maybe I didn't. A count of the number of successes in N trials. And so the way we would represent our X, I'm at the very bottom of the page, y'all. The way we would represent our X, what you do is you start with 0, because there's always a possibility that there are no successes, right? And then the next possibility would be that there's 1 success, 2 success, 3 successes, and it would go on in this manner indefinitely until you reach the number of times the trial is repeated. Okay, so if the number of times that we repeat this trial is 6, our X is 0, 1, 2, 3, 4, 5, 6. Like you stop at what your N is. That's what that's saying. Okay. Okay, everybody good? Okay. Now we've got 1, 2, 3. We've got 3 examples where we just identified the N, the P, the Q, and the X. Okay? And then we're going to have 2 examples where we use the formula I told y'all about, and then the last one's going to be actually creating a binomial distribution. This one, yeah, I can get it. I'm lazy, I ain't getting up. Okay. So, example. Sorry it's so messy. The one that I wrote last night at home is much cleaner, but my markers are dying. So, example. What we're going to do is identify a success, comma, specify N, P, and Q, and list possible values of X. And whenever you do these, y'all, the very first question it actually asks you is this a binomial experiment? Right? So if you go back to what we defined, they can't affect each other, right? That was like the main thing. So if you notice that within the different trials, something's going to affect something else, you just immediately say no. And we do have an example of that. But just know that that's actually the first thing they ask you. Okay? So for our first example, we have a certain procedure. Nope, that's not how you spell procedure. Has an 85% chance of success. Eight patients have the procedure done. The random variable represents the number of successes. I know it's going to run out of room, so I did hashtag #. And so remember, the very first thing on the homework, it's like, is this a binomial experiment? So you have to think about all the different trials that are happening. We're talking about there being 8 patients having this procedure done. So that means we have 8 different trials happening. And if you think about whether or not a procedure happening on one person affects somebody else, it doesn't, right? And so because of that, it is independent. Like all the trials are independent of each other. Therefore, it is a binomial experiment, which means we can identify our N, our P, our Q, list our X's, N, P, Q, and X's. Yep, that's it. Okay, so yes, it's binomial. They don't affect each other, independent. And it's going to have N, and it's going to have a blank, and you're going to put your N there. If you go back to page 1, we defined our N as the number of times the trial is repeated, right? So the number of trials that's happening is our 8 patients. Okay, so our N is 8, which is the number of trials. And then once you hit 8 and you hit enter, it opens up another little blank and it asks you what our P is. Okay, so our P, if you go back to page 1, it was a probability of success in a single trial. So 85%, but if it's the probability, we're actually going to like kind of denote it or write it as a decimal. Okay? And so our probability would actually be 0.85 because that is the probability of success. And also for Q, it wants to know the probability of failures. That little formula to figure out Q was 1 minus P. If you do 1 minus 85, like now you're dealing with negatives and that can't be a probability. So that should also be like a hint that it needs to be changed into a decimal, right? Because right here, Q is defined as probability of failure in a single trial. And on page 1, I said that the way you find P is to take the number 1 and to subtract, the way you find Q, I hate when I do that. The way you find Q is to take the number 1 and subtract your P. So I put P into a decimal form so that I can do 1 minus 0.85 and I get 0.15. Which honestly, I know that a lot of y'all can do that in your head. But I'm trying to say you can't. But grab the calculator so you don't mess up. This is probability of failure. What other outcomes do we have? We have success and failures, and was there another one or no? No, that's it. We have 2 outcomes. Whenever we deal with binomial experiments, we have the probability of success, we have the probability of failure. After you identify the number of trials, success, and failure, what we do is we need to list the possible values of x. X was defined as a count of the number of successes. And x is a random variable, and it says represents the number of successes. Remember I said it's literally a list. Now you start at 0 and you go up to what? N. So our x is equal to 0, 1, 2, 3. Establish a pattern and then use an ellipsis and then end at your n. No reason at all in the world, unless the homework tells you, honestly, I might be a lie. The homework might even tell you to list all of the possible ones, right? And you would do it in consecutive order. If it allows you to do ... this just means that all the numbers in between 3 and 8 are listed right there. For my sake, with all the writing we're going to do today, I'm definitely going to ... it. That one's fine. It's this one that I care about, Anita. Thank you. Does that make sense, y'all? Okay, the first handful of problems is literally just identifying number of trials, P, Q, X. And first and foremost, though, you have to check to see, like, is this even a binomial experiment? Like, whatever I did in this first trial, is it going to affect the other one? Because if it does, you just say no. If it doesn't and they're all independent, you move forward. Okay? Second example. Myth. I think I can. Maybe that one. Okay. A jar, like an actual jar, a jar, contains 5 red marbles, 9 blue, and 6 green. You randomly select 3 without replacement. Someone should instantly know what the answer is, if y'all listen to me. The X represents the number of red balls. When I say balls, the number of red marbles. Math. Okay. So, very first question on the homework. Is this a binomial experiment? Why not? If we put the marble back, the next time I go to pull out a marble, that trial had nothing to do, that trial wasn't affected by the first one, right? The first one had nothing to do with the second one. Right now, all we're going to write is, it's a long sentence, but I said since the marbles are not replaced, the trials are not independent, therefore not a binomial experiment. So we can say marbles are not replaced. I need a cough or something, my throat. Comma, trials not independent. Therefore, not a binomial experiment. Make sense? Hopefully. If they're independent of each other, we could say yes, find the n, the p, the q, the x. If they are not independent of each other, straight up say no, and move on to the next problem. Okay? And I've got the pages here, y'all, so once you need to come grab it, I probably wouldn't do it and then get behind on other pages and snap a picture later if you need to. Whatever you want. Okay, third example. This one's a little bit wordier. Okay. A survey asked 5,000 students. Quote, have family obligations forced you to reduce the time you spend studying? And y'all, believe it or not, I actually took sentences out of this example, so they're wordy on there, okay? Have family obligations forced you to reduce the time you spend studying? Okay, so survey 5,000 students. Have you had to reduce the time that you spend studying? 66% say they have reduced the time studying. We should just be able to say they have reduced. I love shortening sentences. Until you go back later and look at it and you're like, what in the world was I saying? Mm-hmm. 50, so many numbers. That's what I think could be difficult, is reading through it and being like, okay, which number was important, right? So 50 students are randomly selected. Period. X represents students who reduced study time. probably could also divide that, but I am curious if anyone wants to, don't do it. If anyone wants to like guess, or explain why this is or is not a binomial experiment. I've got 5,000 people who've been surveyed. I've got 66% of them saying like yes to the survey. Then I've got 50 people who were selected. As far as it being a binomial experiment, I'm trying to think of the trials, right? The number of trials that occurred and if they're independent of each other. Okay, it's not the 5,000. Okay, 5,000 is like the whole group of people who were surveyed, but this experiment was done on the 50 that were selected. Okay, now out of these 50 people, were their responses independent of the next person's response, or did something I say on my survey affect Katie's survey? Like, wouldn't they be independent of each other? Does that make sense? Okay, like I'm gonna fill out a survey, I put it in the box. Whatever I put on that survey did not affect whatever anybody else put on that survey. So all of these trials are independent. Okay, so don't let that first number throw you off. However many people get randomly selected, that's gonna be your N, because that's the number of trials that we're doing this experiment on. Okay, it came from that bigger group of surveys, but 50 is what we're working with. Okay, so, and they are independent of each other. Just make sure you understand that too, because if not, the answer is just no and you move on. But I think if it says without replacement, that's your hint that it's not, right? That's that previous example. So our N is 50, because this is the number of trials. I'm using that 5,000 person group of surveys to conduct this experiment, and it's on only 50 of them, okay? Now, there was 5,000 that were asked. A certain percentage said yes, and then I'm pulling from that whole group 50 students. So when it asked me what my probability of success is, here, what did they say? So X representing the ones who did reduce it makes the 66 who said, yeah, they reduced it, the success, okay? Where they have that percent, that's your success. You kind of calculate that, the failure, okay? So any percent that you see in your problem, that's your success. But 66% as a decimal would be 0.66. And y'all, seriously, if that does not make sense, definitely let me know. You're putting the decimal at the end where it belongs, and you're moving it 2 times to the left, right? That's how you convert. Or put 66 in your calculator and divide it by 100.66. Okay, you go into a decimal by dividing, you go away from a decimal into a percent by multiplying, both times by 100. Okay, but don't let something like that mess you up with these problems that can be really, really long, because I'm not even lying. I used a whole thing of whiteout last night because I messed up on one thing. It was so much fun. Okay, so probabilities of success, that's my 0.66. I should have just done P of S, because that's probability of success. And then it wants to know, what's my Q? What is Q? Q is probability of failures. 1 minus 0.66. Okay, both of y'all, yes. 0.34. This is probability of failure. Look at that. Look at that shorthand. It's like my favorite thing in the world. It's like acronyms and just making something as tiny as possible. Okay, X represents the students who reduce their study time, which we're talking about the number of trials. X is 0 up until you get to N. Again, unless the homework wants you to type out all of these, which I highly doubt it. I just don't remember. I go straight to the examples and I just work on them there. Personally, like on the test, I'd 0, 1, 2, 3, ... 50. That quite literally tells me all of the numbers from 3 to 50 are included right here in this ... But in math, we are inherently lazy and we shorten things as much as possible. There's no reason to work harder when you can work smarter. Does that make sense? That's the first chunk, first handful, just identifying things, okay? Okay, now we're gonna do that formula. I fell in love with this formula last night, y'all. I really did. I ain't gonna lie. I'm a nerd. Yeah. And then I made this really awesome joke on the board today in the office, and I put it on my Instagram, and I even hashtagged it. I'm a nerd. Like IMMA nerd. I am the biggest. Really am. I love math so much. It's beautiful. Okay. I want my cut markers. What is this one? I think it's thin. I think that's why I don't use it. I need to write on myself. Oh no, that's boo. That says 5 point. I need to write a note on my hand. It's going to be the only way I do anything.
Where's the cheerleaders at?
They're never here.
They're over here? Like,
Binomial probability formula.
oh, I thought you meant like something because of cheer. That's why they're not in here.
No. Binomial
This is
probability.
page what?
This is my page 4.
4. So we only have 2 more?
Well, I mean, I might write bigger or smaller, and so yes, no.
How many of these you got?
I have 8, but this last one's not really a page, so I'm thinking it'll end up being 7 on my end. But I usually
I'm
can't.
on the, I'm just on the back of mine.
Well, it's because you write tiny. I
Alright,
can't.
That's how you're supposed to write. You write big. You got space.
So I could have to write bigger for these problems here or smaller. I just kind of go with the flow. I don't put much thought behind it, Tyler. You're going to make my Sharpie stop dying, or stop working and start dying. So y'all, for my birthday, that's what I want. I want black markers, okay?
When's your birthday?
It's coming up.
That's a great answer.
It's in February.
In February?
Yeah, so it's always coming up.
It's not February.
It's coming up. The probability. Okay, so binomial probability formula, okay? We use this whenever we are calculating the probability of exactly X successes in trials. So just read that sentence again. The probability of exactly X successes in trials is, right, and that comes from N is the number of trials you're doing, and then X was the possible number of successes, right? That we could happen none times. We could have the success of 1, 2, 3, 4, all the way up to N, right? So we're trying to figure out exactly how many of my X's occur with that many trials. We use this formula. And it actually shows it to you in 2 different ways. I use the first way because I think it's easier, and I'm going to show you in your calculator what buttons to push. The other way would be more of like a computational by hand. If you get lost and you click view an example on my math lab, it shows you the other way sometimes, and then the first way sometimes. So just don't get confused. Ask questions if you need to, okay? So, the probability of exactly X successes in trials is. So we take the probability of X, and this is equal to, do y'all remember the, like the combinations? It was like N, C, R, N, choose R. Right? N was the total number, and then R was the number that we're choosing. With this formula, it's actually NCX. Okay, so N is the total number, and we're choosing X of them. That's what we start with. Okay?
Is that NCP? And the NCX?
N, no, we're not going to do probability. It's just going to be the combination. Just the combination formula here. So we have NCX. And then we're going to multiply that to our probability of successes raised to the X power. And then we multiply again with the probability of failures raised to the N minus X power. I'm going to define everything, and I'm not even lying. It looks worse than it really, really is. Like, I'm not even kidding you. I'm really not. Okay, now this is the one I use because it's so much easier to put into your calculator. We know the definition of that combination, and so what they do, if you see this, right, n factorial over open n minus x close factorial x factorial. We did this. This is when we did the combination. The only difference is now instead of an r, we have an x. Okay? This is just that NCX. That's all that is. So after we do this, we would multiply it by p to the x, q to the n minus x. Again, though, I'm only working with that first chunk of the formula. There's really no reason at all to expand our combination out like this when I'm going to show you where that combination button is in your calculator. Okay. Now let me go ahead and define like what all these little bitty pieces mean. Okay. So we have our n, which we know is the number of trials. Our p is the probability of success. Our q is the probability of our failures. Our x is the number of successes. Very redundant. We've literally already kind of defined these. On my p and my q, I'm writing them differently, but that's probability of what was my s. My s was the successes, right? And then this q is the probability of failures. If you wanted to add here, you can. This is found by 1 minus p, right? And then there's just one little note, because there's something slightly different right there. That's the one we're using, right? There's something slightly different in the exponent of our q, and it's the fact that it's taking the n and it's subtracting the x. Okay? Our note is that the number of failures is n minus x. Not the probability of failures, that's q. It's the number of failures. Okay? If I take the number of times I perform this trial and I take out, right, I subtract away the successes, what I end up getting is the number of failures, right? X is number of successes. N minus x, number of failures. Okay, so that's all we need to know to go ahead and move on to the first example. I'm going to give y'all just a second to write that. And actually, you know what, since I don't love and hate this big huge screen, we're going to end up changing pages. I know y'all will see, so I'm going to just be able to have this up here. And so when we figure out the probability of x, it is NCX, q to the x, q to the n minus x. I'm very excited with you. Just in case I like refer to it or whatever, I don't have to flip pages, y'all have to flip pages. This is where I said math is about patterns. If you can find a pattern and make the work a little bit easier on yourself, stick with that pattern, okay? Just how things change, that's all math is. You ready? Example. Okay. 72% of adults have little confidence in the news. Y'all, the example on the homework I think says in the newspaper. Okay, so I pretty much did it almost verbatim, following the 4.2 homework, okay? 72% of adults have little confidence in the news. 10 adults are randomly selected. Find the probability, right? Previous, remember, it just kind of gave us information and it was like, oh, identify N and P and Q and X. Here it's actually find the probability. That's why we use this formula, because it literally said find the probability, okay? Find the probability that the number of adults, it's just so much writing here, who have little confidence is, okay, we have A, B, C parts. Okay, and that's, in all honesty, that's why these problems seem to get kind of long, is because they have multi-parts and because you do the same formula over and over and over and over and over again. Okay, A, exactly 8. B, at least 8. And C, less than 2. So you really have to understand exactly greater than, between, inclusive, less than, right? Obviously, like, we've been having to care about that, and we still do. So, let's go ahead and let's start working on part A. Before you can actually figure out the probability, you still have to define N, P, Q. You still have to define all of that, okay? So for A, my N, that is the number of trials. Please, somebody tell me how many trials I'm doing. Yep. My P is the probability of success. What's that? 0.72, right? Just make sure you convert it into that decimal. You know, if you put a 0 in front of it, that's fine. I'm just lazy. I'm sorry, I don't. I usually don't, okay? Q is going to be the probability of failure. What's the probability of failure, somebody? 28.
Can't you just take it for 72%?
Yeah. Well, I mean, technically in my mind, I know 70 and 30 make 100, but I got 2 more, so I'd subtract 2. You could do the P and the Q in your mind. Y'all, I mean, you should be able to. If you can't, it's not a big deal. Ooh, calm down.
I'm confused on how 1 minus 0.72 equals 3.
Because it's like almost backwards looking, yeah. So just put it in your calculator, because right here, if you mess these numbers up, you're going to probably be very mad at me in life and math the whole time you're trying to do your homework. So don't mess up something simple like this, because it will mess everything else up, okay? So my X. What's my X? My X is a count of the number of successes, right? When we're doing A, yes it is. Your successes is X equals 0 to 8. I'm sorry, to 10. But when we're specifically doing A, what do I care about?
8.
Exactly 8. So what's my X? 8. Now, if all it wanted was your number of successes for just the problem in general, right? Don't pay attention to A, B, or C. It is X equals 0, 1, 2, 3, 4, 5, 6, 7, 8. Whenever you're doing these different parts, you have to read exactly in between, inclusive, less than, greater than. That's what defines your X's. And then you work with those, okay? So, now we can do this. It does tell me round 3. Y'all, in my notes, I just said round 3. For y'all, I'm actually like writing all these words. Round 3 decimal places. Round 3 should be pretty self-explanatory though, in my mind. Okay, so what am I doing? I'm finding the probability. I done covered up my formula on the board, P of X. What's my X? Oh, what's my X? 8. So I need to figure out P of 8. Okay, now what I do is I use that formula that's on the board. I kind of already had it covered up on my page, and I don't want to scoot down too much right here, okay? So it starts in a subscript, N, and then a capital C, and then an X. N, I've defined that. That is a variable that can be changed. So I do 10, do your capital C. That's not a variable. That actually means you're taking a combination of, right? And it's 10C what? 10C, my X is what? And then if you look at that formula, y'all, there's not an operation in between the combination, our P, or our Q, right? Because they're all kind of smushed together, that implies multiplication. So what I do, I know I'm going to take the combination of 10C8, then I'm going to multiply it with what? My P, which is 0.72. Use parentheses. That's my P, right? Put it in parentheses because everything's going to be multiplying. And then what do I raise P to? What do I raise it to? The X power? What's X?
8.
Okay. And then now I'm going to multiply that to what? My Q, open parentheses, okay? And now I raise Q to N minus X. N, and I'm just going to write it all here, but you'll notice in a minute, we're going to stop writing the N and then the minus and the X. It's usually fairly simple, and you could do 10 minus 8 or 10 minus 2 or 12 minus 3, okay? But N is 10. And we subtract our X, which is 8. And then we have that the probability of 8 equals, we're going to round it to 3 decimal places, but you need your calculator. It's the only way you can solve these. Nah, I lied to you. If you use this part of the formula, right, where you actually break down that combination in CX, you can do these by hand. It just might not be pretty. Exclamation is factorial. We learned that. Spent a whole day on factorials. That's not really like a very pretty equal sign. Y'all ready? You would use that if you wanted to break it down further. But you would have the ability to expand your numerator until your largest factorial and your denominator and cancel them. No reason, right? Okay, so y'all ready? Turn on your calculator. I think it's good practice. I always hit clear. I'm like a freak about it because I don't want something to be in there in my memory and then it mess it up. They hold things against you, like friends that no longer like you, okay? So, I, notice right here, 10C8. You start with the 10. Just literally 1, 0. This C is for a combination. That comes from the probability function under your math button. You touch math, and some are slightly different than mine, okay? But in mine, I'm highlighted right now on the top left, it's math, and then it's number, and then it's complex, and then it's probability, and then it's fraction. I want to go to probability. It's actually going to take me shorter to go to the left. I did math, highlight probability, and you see that third option, NCR? That's what we're doing. It's just now no longer an R, it's an X, okay? But it's the third option. You can either scroll and hit enter, or you just touch the number 3.
How do you put Q in there?
Huh? If you stop, you'll learn. No, you're probably already ahead of me, and you're probably all up in your subscript right now. So wait a second. Okay. Don't worry about. Well then, no, don't work for it. Don't work for it. What I put here, it's blinking in the second subscript where my X should go, which is my 8. Now, don't do what I'm fixing to do. That's it. That's your calculator just shows NCR instead of a C. It's the same thing.
I don't like that.
Yeah, it is different. Okay, so in my specific calculator, if you have an 84, do you notice how it's blinking on the 8? If I keep putting numbers here, it's staying down in the subscript area with that 8, right? And obviously, I only want 8 there. So I need to get out of that area by pushing over to the right, and it pulls your cursor back in line with where it should be, okay? Now, what do? I open 0.72, close. Yours should automatically pull out because it does it in that manner. Yeah, so you should be good. Okay, and then what is on my probability of success, which is open 0.72 close, is an exponent of 8. You hit your caret button, which is above the division symbol. Type 8. Don't keep typing here because you're going to stay in the exponent field, right? You got to scoot over again to the right to get out, and now you're in line with everything. And then open 0.28 close caret. Y'all, 10 minus 8 is just 2. It doesn't matter. Either way. I'm just letting you know, moving forward, if I kind of don't do that subtraction, it's because if it's simple and you can do it, then just do it. There's no reason to work harder. There's no reason to type one extra button if you don't have to. Remember, I'm all about shortcuts. Shortcuts that are good shortcuts. So I get 10 minus 8 is 2. Okay, and you hit enter. And it told me to round to 3 decimal places. Personally, I'm going to do 0.25479. I'm going to list a few, and then I'm going to round. Okay, this is just to keep yourself from making an accidental simple mistake. Round 3 decimal places. I start at the decimal, and I go 1, 2, 3 places over. I underline that one, and I point at the one next to it. Lots of work that seems elementary, but this is actually one of the things that confuses people more than anything. Okay, 4 is the one I'm trying to see. Does it stay, or is the number 1 added to it? 7 is what tells me what to do. 7 is greater than 5, therefore I'm going to round up. And so what I end up getting for the probability that that there's exactly 8 people out of the 10 that I asked with the whole newspaper, whatever, is 0.255. Now y'all know my math lab, or my stat lab, or whatever it's called. You don't round right, it's going to tell you no. You mess up one little thing, it's going to tell you no. Okay, so make sure y'all understand this, because that might be as slow as I'm going to work through that problem. Everybody good? That was part A. Now we're going to do part B. Okay. Part B says at least 8. So I need to change pages, obviously. Man, why did I do it in black? Okay. Purple, right? Okay. What did it say? At least 8? I just kind of rewrote it again so I don't forget. That's just like for my own as I forget things. Okay, so thinking about this problem, the N is the number of trials, which is still what? That didn't change, right? What about the probability of success when I go on and I'm, getting the probability of at least 8? That also doesn't change. Which means my probability of failures does not change. Okay, what changes within each of these different parts of the problem is your X. Okay, I need to think about this for a second, because if it is going to be at least 8, that means that 8 is the least amount, which means it's the smallest, right? So at least 8 would mean I start at 8 and I go up until N, which is the number of trials. This is at least 8. And then what I'm ultimately going to do after I find each of their individual probabilities is I'm going to sum them. And here I'm told to round 6 places. So in order to figure out the probability that it's at least 8, I figure out probability of 8, probability of 9, probability of 10, add them all up, that's your answer. Okay? So let me go and do that. Probability of 8. Didn't we just solve that one? How? It just did this a minute ago. Getting quicker and quicker, I think. Okay. Didn't we just solve the probability of 8? In part A?
No.
Huh?
No.
Yeah? Yes, we did.
That was not 8.
Probability of 8?
It's not 8. It's not 8. You
What?
see that 9 right there?
What?
What do you want?
This is the probability of 8.
That really says 9. That really says 9, look. You
Where?
don't see it? Right there.
Okay, stop. I was pointing at 8. And we just solved it, right? So, but the thing is, do you see how in this problem it tells me to round to 6 places? So I need to look at my calculator. I just solved for 8. This is like a shortcut. No reason to put it all into my calculator again. So I'm going to round this 6 places. I have 1, 2, 3, 4, 5, 6. You should have 0.254794. Okay. If you want to write it all out and put it in your calculator, you're going to get the exact same answer. There's no reason to. I just solved for probably
It's not the
8.
It's 0.255. Actually,
Where did it tell me to round here? Now what do I do? Find the probability of Avery and Tyler's favorite number, 9.
no.
Now this one I didn't just solve. I need to actually solve it, right? So let's solve it. It's n cx. What's n? 10. C? P of x. What's x? Probability of success, 0.72, raised to the x power, which x is now what?
Oh, so we're just changing the living numbers.
Barely any.
Pattern.
What's probability? I'm sorry. Oops. What's x? 9.
9.
And then multiply it to the probability of failures raised to the n minus x. N is 10. Here, right now, my x is 9. 10 minus 9 is 1.
Wait, what's that
And guess
power
what?
I'm talking about?
Because it's raised to the x power. P to the x. Right here, look at NCX times P to the x. So you notice how your x's right there stay the same? Now wait, you don't have to do that yet, y'all. Let's do this first. Literally patterns. Watch. Probability of 10. Let's do this one. 10 C what? Open 0.72 raised to the 10. Alright, because this is an x and here's my x. Then multiply it to the probability of failures raised to the n minus x.
So 10 is
10 is what?
0.
Have your equal sign right here. Now let's pick up my calculator. Y'all, look it, and this is why I'm saying this. This is what we're going to do in a minute. Okay? And then the last problem, we got like 8 to do if you want to do it correctly, and it sucks, but we're going to do it. And so it's like, why do it, pick up your calculator, do it, pick up, you know what I mean? Like, go ahead and write everything out. Follow that pattern that you notice, and then pick up your calculator, because watch this. Do you notice how very little things changed? Right? So if I go up, I don't know why I copied that. I didn't mean to copy that. It doesn't matter. If I go up to here and I highlight, y'all can't see it, but the actual formula is being highlighted in blue, and I hit enter. Stupid. Let me just make sure that it's clear, okay, and not like stored anything in memory. When I highlight it and then I hit enter, do you see how it copied it and it pasted it? So now I want to figure out probability of 9. So when I use my cursor and I go all the way here, do you see where that was an 8? I touched 9. Now it's a 9. Then I'm going to scoot over because nothing here changed until that exponent. Now it's a 9. And then I go all the way over here to this other exponent. And now it's a 1. Let me see your calculator.
I'm not going to do that.
I just did it.
Oh,
Come here.
that's the way.
So if you highlight it and hit enter, and scoot over. Literally the exact same steps I just did. So what I get here, remember, round to 6 places. So 1, 2, 3, 4, 5, 6. You should have 0.145596. And then I've already written all the work that I'm fixing to do down on my piece of paper, just in case something ends up being wrong. You can recall and you can look through it. But I did that so that now I can do all my calculator work, right? Instead of calculator, paper, calculator, paper, calculator, paper. Let's smush them together. So go up again and highlight it. Hit enter. So it's the exponents that change, and it's the little subscript after your C that changes. So now you'll have to watch this, because if you don't do this, you could mess up. Right here, it's NCX, right? I'm replacing this 9. Tyler, definitely watch so you don't ask me after I explain it. I'm replacing this 9, which is a 1-digit number, with a 10, which is a 2-digit number. Okay, if you don't do this, it's going to like kind of wipe things out. So I'm going to touch the number 1. I need to put a 0 there. Oh, no, yeah, you're good. Let me just make sure. And then 1, 0, and then 0. Okay, I thought I was going to have to like insert something and I didn't have to, so we're good. It allowed me to just type in the 10 for the x down here.
So when you type down the number.
Type in, you should just, let me see, because I wonder if your calculator is why I said that. Okay, so I'm just going to go up and I'm going to grab this one. And I'm going to go all the way. 1, 0. Okay, yeah, yours does it. Okay, so. It should be fine. I'm going to try one more time. You see how it like deleted things?
Mm-hmm.
Okay, so his actually does delete things, which is what I started to show you here, but mine doesn't delete. So if you go up and you grab it, since 9 is a 1-digit number and I'm replacing it with a 2-digit number, I can touch the 1 on the 9. But to keep it from replacing that parenthesis, I need to do second delete, which is actually insert. And now it let me insert it, the 10. 1, insert a 0. And if this is like, nope, then you could just redo the whole entire formula again. And then 0, delete, delete, delete. And you get the same thing I got. That one just takes a second longer, and it's literally just the difference between an 83 and an 84.
You said what's
Second, and then the delete button, once you hit the second, you're actually going to be inserting numbers. And that's whenever you notice that things are being replaced. And like, I don't want that to be replaced. I actually want that 9 to turn into a 10. This one just allowed me to insert everything in there. Okay, so what's it call it? 6 places would be 1, 2, 3, 4, 5, 6. 0.037439. And then did you see here how I said we're going to take the sum? I did all that work to actually answer this problem, which if we're going to find the probability that the number of successes was at least 8, that means that it's greater than and also equal to 8. You might see this notation, which is why I'm doing it. Okay? And the way you solve this is to sum together the probability of 8 plus the probability of 9 plus the probability of 10, which is going to equal, I actually wrote everything out. I'm just going to pick up my calculator. Don't add together the ones that you have in here that haven't been like truncated or shortened, because it could end up being wrong. I would just retype all of these. Okay, I would do 0.254794 plus 0.145596 plus 0.037439. And it tells you, because it tells you to round differently almost every single time you do something. Okay, here for the answer, it wants us to round it to 3 places. So I get 0.437829. I'm in math, gotta be accurate. 3 places. 8 tells me to make that 7 and 8. So the probability that it's at least 8.438. And that's literally like, I feel, I don't know, 75% of the homework is this. Okay, there's, I think, 2 problems where you do the distribution thing. And then, I don't know, maybe... Yeah. I just took all of this, and then I added it to the probability that there was 9 successes, and then I added it to the probability that there was 10 successes. So the probability that my number of successes was at least 8, which means it includes 8 and is greater than, was the sum, which is why I wrote right here. Like, we're going to find each of them, and then you sum them. Okay. Now let's do part C. What does part C say? Less than 2, I believe. Okay, what's my N? What's my P? What's my Q? And what's my X? Less than 2. I've got all the different, X is all everything up to N, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But for here, I'm only concerned with or doing the x's that are less than 2. 0's less than 2. 1's less than 2. 2 is not less than 2. So you stop there. It's just 0 and 1. And then what am I going to do whenever I find them? Oh, that's an ugly race. Yeah, so is that. I'm going to sum them. And it tells me to round to 6 places. So, probability of 0. Now guess what? On the test, this is a calculator problem, so there's really not much work that would go behind it, so you need to know how to use your calculator. On your homework, I'm not home with you. I'm not watching you put it in your calculator. The homework will either tell you you're right or you're wrong. If you understand that all I've got to do right now is change those few numbers, you don't have to do what I'm doing. I'm doing this so that later you can look back and be like, how did she do that? Oh, okay, that's what changed. Okay? But you quite literally could just pick up your number, pick up your number rater and do 0 and then do 1 and then add them and then put it on the My Math app. Okay? I'm doing all of the steps. So, in
Wait, that's when it's automatically going to give you the
CX. What do you mean? This is still the same problem we've been working on, so that's why the N, P, and Q are still the same. They haven't changed. So NCX times our P raised to the X times our Q raised to the N minus X. N is 10, X now is 0. So 10 minus 0 is 10. And then I'm going to also figure it out for 1. Okay, so 10C1, open, 0.721, open, 0.28, close, 9, equal. Doing the formula that's on the board, the exact same way we've done the other 6 times that we've done this. I'm just doing a little bit quicker because you should notice, I wish I had a highlighter. It's probably going to jack up my marker or something. Hopefully it doesn't confuse anybody. But I'm going to use this P of 0 as an example. The only thing that changes whenever I've done this is that. That's it. Everything else remains the exact same. My N does not change. In this particular problem, right? Within one problem, your N does not change. Your P does not change. Your Q does not change. That C is a C and it ain't going to change. But your X changes, and both of these first values right here that you see, that kind of surround that P, they're the same. And then at the end, you just do the subtraction of N minus X, which is the formula. So I pick up my calculator, and I go up to the last time I entered this problem's probability for another one, right? And I just scooch all the way over. What am I doing? Okay, so right here, I had a 10. I only want 0, don't I? So that button that says DEL, that's delete. If you actually delete the 0 and not the 1, it's wrong. So make sure you delete the proper one. And then I'm going to scoot over. That stayed the same, but this exponent changed to a 0. Hey, there's no problem at all with you using your calculator and entering it in every single time. Hey, I'm all about trying to show y'all how to do it in a shortcut manner. I'm expecting y'all to be like, hey, you're crazy, I have no clue what you're doing, and actually speak and let me know if you're lost, okay? Huh? Meh. Oh, what? Nope, don't do it? Okay. Can I see it? Okay, and then the exponent here, it's now a 10 because it's N minus X. 10 minus 0 is 10. Okay, now let's see. This one is an 84 plus. It should. Okay, so yours, probability right here, PRB, and then there's your C, the third option. So the only thing is it's missing the fraction one. So it's a little bit more smushed, but it is there. Okay, here's just like Tyler's. So we have 10, and then math. Scoot over to probability. That third option is your C. And then now you see yours is NCR. Mine changes, it's just, I don't know why it's different because they're both 84 pluses. Mine's a silver edition though, and it's a color screen. Flex, just kidding. So here we got what, 0. And then this one, there's not really like you're not existing somewhere like where my 0 is to where you got to scoot out of it. Okay, you doing that number after the NCR, you've now completed what it needs you to do, and you just move on to the open, 0.72, close, caret is right here. Oh, it's a bit much, yeah. And then I got a 0. Now I am blinking in the exponential field. I have to scoot over. Good? Okay. Well, now I'm going to finish it for you. So, doop. Okay, that is what you should get. You're welcome. Okay, now, whenever you hit 0 here, pretty much everybody should see what I see, which is, I should have put a little bit of space here. I've got 2.96196, and just, you can end it there, e to the -6. This is scientific notation, which means that this is either a huge number and it's too big for your calculator to show it to you properly, or it's a tiny number, okay? What the sign is on that exponent with your e, it tells you to move your decimal to the left or to the right. This is a negative, so I'm going to move my decimal 6 times to the left, okay? So what I would do, I'm going to do it in blue, and it's going to be messy, but it should be okay. I didn't look down to know where I was going, or I would have left room. I pick up this decimal, and I move it 6 times to the left. So I go 1, 2, 3, 4, 5, 6 new decimal placeholders. 1, 2, 3, 4, 5. Right? But I need a round. Let me go ahead and kind of rewrite this so it's a little bit cleaner. I've got 1, 2, 3, 4. I had 5 zeros. Don't think that you're done rounding. All we did was move the decimal, right? Put a few numbers. 2, 9, 6. Doesn't matter. Now round this to 6 decimal places, okay? Now if I do that, 1, 2, 3, 4, 5, 6 is my 2. I look at my 9. 9 tells me to go up. So the answer to the probability of 0 with all of this data is 1, 2, 3, 4, 5 zeros and a 3. I don't believe, I kind of squared it because there's a whole bunch of hot mess going on there. I don't believe that my stat lab, my math lab is very forgiving to where even you doing doing it to 2, it's probably going to tell you that you're wrong. And you'll be off literally by whatever thousandth place that is. So make sure you understand that. If you don't, let me know. So now we need to do the probability of 1. So turn on my calculator, I highlight, I go all the way over. The only thing that changes is this 1. And then it will be n minus x, so 10 minus 1 is 9. Yep. And then we have 1 here. And then I've got a 2-digit number here. If I do a 9, it looks like 90. So I need to delete and hit enter. And then this one, I also get an exponential, okay? And so, like a scientific notation with an exponential. So I'm going to write it down. I got 7.6164, few numbers, e to the -5. Y'all, if I'm moving the decimal 5 times to the left, I'm going to add 4 zeros in front of that whole number. Shortcut, little shortcut there, right? Hopefully that makes sense. So what I have is 0.1234 zeros, because I moved it 5 times. 7616. We're in math. Gotta be as accurate as can be. 1, 2, 3, 4, 5, 6. 1, stay. 6 is what I'm seeing if I round. 1 is what I look at. It tells me to stay. I just skipped a few words. No, the answer is 0.000076. Let me just double check. So 7.6164, I just did it a couple of times. E to the -5. -5 means move 5 times to the left, which would essentially put 4 zeros in front of your 7. But 1, 2, 3, 4, 5 new. 1, 2, 3, 4 placeholders. I rewrote it so it wasn't so messy. 0.0000716. When I look and it tells me to round to the 6th place, 1, 2, 3, 4, 5, 6 is what I'm trying to see. Does it stay or does it go up 1? 1 is what I look at. 1 says stay. Therefore, it would just, that 1 and that 6 kind of fall off. So the final answer is 0.4076. And then for the last step, you sum them. The probability that my successes are less than 2 would be notated with x's less than 2, right? Probability of x less than 2. And what I do is I take the probability of 0 and I add to it the probability of 1. And I notice I got a bunch of zeros, a 3 at the end, and a 6 at the end. So you might see that it's just 1, 2, 3, 4, 7, 9. Is that 3? It's just going to add to that 9. I'm sorry, that 6 and make it a 9. But that ends up being the answer. It's like a big puzzle. Let's go take our break, y'all. And then we'll come back. I've got another one like it, using different words like include and this and that. It's just as much work. And then after that, I'm going to show you how to do the distribution and it will be done. Okay? I said, do you need something?
Nothing.
Nothing?
Yeah.
Oh, y'all.